right, we are back with Mr. Jeffries Algebra 2. Today we're diving into graphs of rational functions. Um, Remember, I'm not a very big fan of graphing on paper. I think it's archaic. But we get to know the characteristics. By the way, we're up to 57 subscribers. So if you hadn't subscribed yet, go ahead, hit the subscribe, hit the like, hit the bell, all that other stuff. And some people just may need to hit themselves. Who knows? Okay, so now this is what's funny. Right now, we are totally ignoring what is on top right here. We do not care what that number is. Uh, we'll get into some of that later, but it's not that bad. All right. So remember, if this is a minus, our value is always the opposite. Okay. So our H value for this problem would be -2. Okay. Pretty simplistic. Now, the quiz that you're going to have on this and what we're learning tomorrow on Friday is going to already have some of this stuff filled out. I've already started looking at that. Now, all right. So I knew somebody would say that even after I said that this is the opposite. Okay, so remember, it's the original thing is the minus h. Remember, h is always the one that's weird. All right, that means our horizontal asymptote is -2. I'm actually going to have the y equals, all you have to plug in is the -2. And then your domain is where x does not equal -2. Okay, basically, it's all x. There's another way to write this, but I'm not going to. I mean, I could show y'all, but y'all ain't going to like it. Yeah. So, all right. So just from that, we get that part right there. All right. Now, our K value, well, right here, it's -1. That means our vertical asymptote is -1, and our range is y not equal to -1. It's like, see, it says like all numbers except, basically, I mean, I really want y'all to write something that says that x such that x is the element of all real numbers and not equal to -2. Do y'all really want to write that? Okay, I didn't think so. That you're pretty much right with by ancient language. It is. It's quite old. It's about as popular as Sanskrit. Okay, the only people that really use that nomenclature is people that are doing like theoretical math and they're trying to prove, this, and this. So what's funny is that physicists actually use that more than mathematicians. All right. So, all right. Yes. Greeks and Egyptians. Okay. So, this right here, our H value. Well, there's nothing under here besides X. So, this is going to be 0. Our horizontal asymptote is going to be 0. And our domain is X not equal to 0. Okay. All right. Our K value, that's this right here. This would be -2. So our vertical asymptote is -2, and our range is y not equal to -2. Okay. Yeah. I know I was looking at this and it was like, graph this, graph. I'm like, no, 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 we're not going to graph. Okay. Seriously, if you wanted to graph, all you had to do is you would Google online graphing tools. Desmos is like the #1 thing. You would type it in, it would do it for you. Okay. Yeah. All right. Number 2. All right, we got to do the opposite. So this is +4. So the opposite is -4. So this would be -4. and this would be x not equal to -4. Okay. And it's kind of funny with some of this stuff how much information you can find out of something so small. Okay. And I'll talk about what an asymptote is later, as y'all are doing some of these other practice. All right. What is our K value right here? Yeah, most people are used to seeing zeros in math, so here you go. So, you know, kind of like that. All right. Our H value, remember it's the opposite right here. So this is 1. So that would be 1. And that would be x not equal to 1. Now, if I just tell you the H and the K and I show you a graph, like I almost did a matching type thing, and I decided that would take up too much paper, that it's pretty obvious. I mean, you would see, oh, this is a horizontal thing. It doesn't touch 1. Bam. Okay. All right. Our K value is 5. That means this is 5. And this is y not equal to 5. Okay. So instead of, and this is what's funny, uh, some of this stuff, like this example and these problems, covered like 2 or 3 different examples on the book y'all don't have. Okay. I don't understand. All right. It makes 0 sense to me. Yeah. Like, and they're wondering why people don't like math. It's kind of like the first time I had to take physics. Okay, so we had this really new professor, just got his PhD that summer, started teaching that fall, taught us theory for like a month, and then gave us a test that had all these equations on it. We were like, what happened? Okay, now because I had to retake it because I, may have made a D or a F, but uh, the other professor I had, she was actually a former high school teacher. She would take 5 minutes of the 1 hour class and say, here's the theory. This is how you use it. And I was like, you are a genius. Okay. So, all right. Now, rewriting. Okay. Now, if you're rewriting this, it seems kind of difficult, but it's not that really. Even I had some of my students that never like to do stuff in second block agreed with me on this. So, first thing we do is we're going to take our bottom right here, which is x plus 1. And yes, it does look like long division, but this is like the shortest long division that you will ever do. It's a superb oxymoron. Yeah. And that's an oxymoron is not a moron that's taking oxy. It's just, all right. Why not? That's our, yeah, I know. So, all right, let's think about it. How am I going to get rid of this x value? What I'm going to have to multiply this whole thing by? How about 5? Okay. Because I'm wanting that x value to go away. Now, here's where it can get a little tricky. A lot of nobody caught this in second block, but I was looking at it and I was like, but remember when you do long division, what operation are you doing down here? Subtraction. Okay. So, 5x minus 5x, those go away. All right. And then 6 minus 5 is 1. All right. Here's what's kind of neat about this. When we are rewriting it, we actually will take what the remainder right here and put it over this like a remainder would look. And then we take this top number and we put it right here. Yeah. We're like, yeah, you're lying again, Jeffries. telling us stuff is easy when it's not. Okay. Now, trust me, I looked at this like 3 or 4 different times and I was like, because I was like, there's no way it can be like this simplistic. Because usually when you hear long divisions and polynomials, it's like, and that's why I showed you what it was and then said, no, we'll never do that in class. And we did synthetic division because that's the way that, you know, it's intended. All right. So for number 5, we take the denominator, put it out here, take the numerator, put it in here. All right. What? 7. Yeah, because I was about to ask it. I didn't know what you were saying. Yeah, we're actually going to have to multiply this by 7. Okay. Now, I'm putting it in parentheses. That way you know, because if I didn't put it in parentheses, this is where I was getting lost reading it, trying to read it from the book, is that I was not doing this part right here. All right, so we know the 7x's will cancel. That's the goal. All right, 4 minus 21 is negative 17. So we have g of x equals, we put our denominator back down here. We put what was right here on top, and we put our whole number to the side. Yeah. Now, again, we're making the main thing the main thing. Okay. I could actually give you a problem like this that says, take this, rewrite it in this form, tell me the asymptotes and the domain and range, and that would be one problem. Now, it would have multiple parts, but it's better than having like 6 of one and 6 of another. Yeah. All right. Now, they're going to do the back of the handout, and y'all are going to make sure that you subscribe, hit the bell, hit the like. Yay. Roll. Yeah, good stuff, good things. Roll Tide.